Okay, I'm introducing to Stefan. Stefan is ingeniero de mina o mining engineering. Y bueno, nos va a disertar acerca de el Borehole. Okay. Stephen, please.
Okay, gracias. Hablo un poco de español, so in English. My name is Stephen Stroud. I'm the Sales and Operations Manager for Robertson Geo for the Americas. I would like to thank Segundo Congreso Venezolano de Geociencias for allowing me to present. So I will go ahead and talk about borehole imaging solutions. Borehole imaging solutions is going to be based on televiewers and borehole cameras. So really quick, Robertson Geo was established in 1979 in Northern Wales. We have bases in the US and Hong Kong as well. And then we have a local representative in Venezuela. It's Frank Zambrano with GeoSol. So he helps out with that market. A majority owned by the Oil Corporation. We design, develop, and manufacture borehole geophysical logging instruments. And we do training and commissioning all over the world. So typical applications for geophysics in general would be site investigation, foundation engineering, slope stability studies, earthquake engineering, on and offshore wind farms, any kind of hydrological investigations, water wells, dam safety, and then we have capabilities of also doing cavities and trench wells. Other things would be any other kind of mineral explorations and low temperature oil and gas. A typical geophysical logging setup would be a PC laptop with your surface unit connected to the winch, and then you choose which tools you would like to run and collect the data with that. For this specific presentation, I'll be talking specifically about borehole televiewers and what those do and what those can provide for you. So why televiewer logging? Borehole televiewers actually they supply you with 360-degree image of the borehole with true fracture orientation. So if it is a coring project and your core looks like the box in the bottom right, where you can't see the fractures and features, you kind of want to know what that looks like downhole. With these tools, not only will it map out what that looks like downhole, but it'll also give you the orientation of those fractures for slope stability studies and other types of rock properties and structural information. It's very useful if you're not coring or in zones where if you are coring and you get no recovery. This is essentially a way to get 100% core recovery utilizing borehole geophysics. The acoustic televiewer, that tool is specially designed to map out fractures, identify the orientation, do the bedding and dip directions. You'll be able to gain lithology, do some stratigraphic studies, local stress breakouts, and you can also use it to orient your core. The unique thing about this tool is that though it only works in fluids in a borehole, it can work in clear water, muddy water, drill muds, polymers. It can see through all of that, and you'll be able to get your fracture detail. And then with that, you can actually process it out and get other types of plots as well. The optical televiewer is going to be the one that actually gives you the true color of the borehole. This one can work in air-filled holes or clear water. It will not work in any type of muddy environments or murky waters, as it is almost like a camera. It needs to be able to see through the fluid. This again creates a 360-degree image, does the fracture orientation, the bedding and dip direction. You can take both of these tools together, do the top part of the hole that is out of fluid, switch tools and do the acoustic televiewer in the lower section. That way you do get 100% of your borehole. These tools can also come with a natural gamma. The natural gamma helps with lithology. They have an accelerometer and magnetometer. And with that, you can also get borehole deviation. So once you collect your data, you're going to need to be able to process it so that you can put it into a report form. That way, when it's passed on to the client, it's ready to go. They know what they have, and they can go ahead and review the results. With GeoCAD, it's a simple processing software where you can pick all the fractures and features in the borehole. It will give you fracture tables that you can plot out, stick plots, stereo nets, Rose diagrams, and all of this can be done, and somebody can be taught how to use this in about 2, maybe 3 hours. So it's very simple to use, very easy to plot out, and provide those reports for the client. So as I had mentioned, you can pick lots of features, fractures. You get your azimuth and your dip direction. You can also do your plots as stereo nets, histograms, Rose diagrams, such as this photo here shows the stereo nets, histograms, the 4 cores. You can do a polar plot, or display all your data on one log, printed out with a header hole information, borehole information, and send that off to the client. And this really does provide very valuable information, especially when it comes to slope stability studies. The acoustic and optical televiewer typically would be used if a piezometer is going to be installed. They would map out the fractures and features, they would install the piezometer, and then monitor slope failure over time. So for downhole cameras, which is different from televiewers because you're not going to get oriented data, this is a quicker way to take a view of the borehole or a cased well, a water well, and see what's going on. The RGOI is a 4-core wireline camera, can also work on coaxial cable, but it works with the surface unit, the winch, and it's just like putting on any other tool. There's no necessary, it's not necessary to have any other surface equipment for this to work. The camera has a pressure rating of 5,000 PSI and 95 degrees Celsius. There are 3 different models, a 1,000 meter, a 2,000 meter, and a 3,000 meter for high quality videos. The visualizer software will take this down view facing camera and turn it into a televiewer style log that you can actually print out and hand to a customer. That way they are not having to watch a video over and over again to see fine details that they would like to see. So as I mentioned, this does create again, 100%, you're going to see the borehole and the sidewalls every time. It will unwrap the image. It will not be oriented as there's no accelerometer inside of the tool. But that being said, it works really well for cased wells that are steel, to be able to still collect a nice video. So this is what the software would look like as it's being processed. You would have your down view, you would have your side view of what it looks like all around. And then you would have a 3D plot as well that you can look up and down and around the hole. On this, it also shows inclination. Again, not direction, but it does have an inclinometer inside. And you could make comments or insert still shot photos that you take while you're downhole of things that maybe you're looking at perforations in a cased well. With this, you can plot out at this depth, I see the beginning of perforations, or there's a hole in the perforations.
Steven, you have 5 minutes left.
Okay, perfect. So being able to take your plots, your videos, your printed pictures, putting it all into this, creating a header, you're able to send that off to a client. Really quickly, other information. Calibration, traceability, and conformity is very important. Clients often want to know when the last time the equipment was calibrated. If you do have a certificate of calibration at Robertson Geo, everything is temperature tested, pressure tested, and borehole tested prior to leaving the facility. And it all comes with a certificate of conformity stating that it has been through these procedures and has been signed off. So you get a date and a signature from the engineer that tested it. Training and commissioning, as I had mentioned, we do training all over the world. And that can be set up with at any time, and we can work with the clients to be able to work on their time frame. One of the last few things is we are members of a dam safety group with our sister companies, Iris Instruments, Geometrics, GSSI, and Kinemetrics. And these are the sectors that we pretty much help out. And I'd like to thank you for your time, and I'd like to thank Frank Zambrano as well for providing the opportunity to do this.
Okay, thank you. Thank you, Stephen. Any question? Yes. Almost. Okay. Sandra, come in here.
Hi, I would like to know how the tool can contribute in earthquake engineering studies. What information we could obtain using this tool?
Okay, for earthquake engineering studies, what you'd be looking at is the fractures and being able to map out those fractures or faults. That way you know the orientation of these features down in the borehole. We actually do have another tool specifically designed for earthquake engineering, which is a PS logger that would give you P and S waves in soft unconsolidated materials. But for the televiewers, it is being able to have true orientation of those fractures and features, and you know which directions these slopes are going.
Thank you.
Okay, thank you. Another question? Okay.
Is it possible to do extra analysis in the core? Example, gas studies.
Okay.
Al final.
Okay. Scorsia says, is it possible to do extra analysis in the core, example for gas studies?
For elasticity? Or, I'm sorry, can you repeat the question?
Okay, Scotia says, is it possible to do extra analysis in the core? Example, gas studies.
Okay. With the televiewers, what you could do is you can actually plot out the data with true orientation to north or wherever you would like it to go, and then orient your core so that everything is north. Other than that, it does not, it won't give you any rock properties on your specific core, besides the acoustic televiewer having a travel time and amplitude, letting you know that a little bit about the softness of the materials based on the time that it takes for the signal to go out and come back. But no, these tools will not tell you any type of properties on your core specifically.
Thank you.
Mm-hmm.
Thank you, Stephen. Frank? Okay. Thank you for your dissertation.
Gracias.
Ok, vamos ahora a